Okay, so let's take a look at concentrations of different solutions. To get started, we need to know how we're going to define concentration. So concentration, which is denoted by the letter C, this is the symbol, not the unit, is typically just expressed as the ratio of the amount of the solute, and the solute is the compound or the chemical being dissolved. So the amount of solute divided by the amount of solvent. And the solvent is the thing that is doing the dissolving. So for the most part, our solvent is going to be water. Now we have a few different ways of expressing concentration for like non-chemistry, household, food reasons. So the first one is what we're going to call the mass volume percent. And it's exactly what it sounds like. So we say percent, and then we'll denote the type of percent we're talking about because we have a couple others with the brackets. So we'll have bracket M for mass / V for volume. So this is known as percent mass volume. And the way percent mass volume works is we're going to take the mass of the solute, and this is done in grams. So this is the mass of solute in grams. And we're going to divide that by the volume of the solution. Volume of the solution. And this is typically expressed in milliliters, ml. Since it's a percentage, we're going to multiply this by 100%. So an example of percent mass volume would be something like dissolving a pack of Kool-Aid into a container of water. So if you had something like, we could say something along the lines of, say you had 3.9 grams of Kool-Aid, right? So it's a powder. It comes in a package. It's a crystal, so it's a solid. You can weigh it in grams. And let's say you have a relatively large jug of water, so something like 2 liters. So we would have to write it as 2,000 milliliters, and we'd multiply that by 100%. So at the end of the day, what we would say is that the Kool-Aid and water solution is 0.20% Kool-Aid mass volume. So the mass volume percent is 0.20%. Another option here is to look at what we call simply the mass percent. And so this is, or percent mass. So very similar to our previous example. We have the percent M/M for mass. Now this one's a little bit weird sometimes because we have a hard time thinking of solutions as not liquids, right? But an example of a solution that would have a mass would be something like an alloy. So a lot of your jewelry is made up of a lot of different metals. So for mass, for percent mass, we again have the mass of the solute in grams and the mass of the entire solution in grams as well. And just like before, we're going to multiply it by 100%. So an example here would be something like a gold necklace. So it's probably not pure gold, right? But let's say that your necklace is weighs a total of 14 grams. And inside that 14 grams, we have only 3.0 grams of gold. So everything else would be copper, maybe some silver or some other metals to help the structural integrity of your necklace. And so we would say that this is 21% mass. The last example here would be what we're going to call volume percent. Percent volume. And this is exactly what it sounds like. So here we have the volume of the solute in milliliters over the volume of the entire solution, also in milliliters, and that is of course multiplied by 100%. So an example here would be if you have an aqueous compound or something that's already a liquid and dissolving it in some more water. So something like vinegar, right, is 5% acetic acid by volume. So that might mean something like if you are making a solution of vinegar, we would say there's 5 milliliters of vinegar in 100 milliliters of your container. And so that 5 milliliters, would be acetic acid. And so that would be a 5% solution. So in a container of 5% vinegar, which is your typical white vinegar, that means that there's 5 milliliters of acetic acid for every 100 milliliters of solution. The last type of concentration that you have probably seen pretty often is parts per. So you've probably heard the term parts per million or parts per billion. So parts per million, we abbreviate as ppm, parts per million. And these are typically done as a mass calculation, but these are for like incredibly small numbers. So we would take something like, again, like before, the mass of the solute, and divide that by the mass of the solution. But instead of just multiplying by 100%, here we multiply by a million, so times 10 to the 6. And this is primarily useful for like extremely small numbers. The other one here that you've probably heard of, which is very similar, is parts per billion. So that's ppb. And just like above, it's the mass of the solute divided by the mass of the solution. But instead of times 10 to the 6, it's times 10 to the 9 for billion. So something along the lines of safety of a certain chemical in food or something like that. Those are talking about parts per million, parts per billion. You've probably heard of the amount of carbon dioxide in the atmosphere measured in ppm, right? So parts per million. So we could say something like, what's the parts per million? What's the concentration of mercury in a fish? So having the correct amount of, or make sure we don't go over Health Canada's guidelines for mercury in fish is obviously very important. So if we find a fish, we're going to look for the parts per million. So let's say we have a fish whose mass is 1.6 kilograms. So that's 1,600 grams. And we do some testing on it. And we find out that it has 0.6 milligrams or 0.0006 grams of mercury in it. So the bottom number is the mass of the fish. The top number is the mass of mercury that we found out to be in the fish. And we'd multiply this by 10 to the 6. So this would show us that there are 0.375 ppm of mercury. Rounded to one significant figure, because that's all really that we have here, would be 0.4 ppm. So Health Canada says as long as it's less than 0.5, we're safe. So this would be an example here where that would be fine.